And thanks everybody for attending. Really excited to talk through this concept of moving past vibes and building production ready AI systems. So today we're going to go into a little bit of detail about what this actually means and how this can be relevant for you, regardless of what, sort of part of the stage of the journey you're on in developing or building these AI systems. So to get started, we're gonna introduce sort of what's holding people back from using AI agents. And this is a Bain Capital survey. We showed this as part of our last webinar. You can see that there are a lot of common issues that people are reporting that are preventing them from being ready to use and leverage AI systems. The takeaway for me here, though, and for us at Arthur, is really what it boils down to is trust. All of these organizations, you and your organization likely want to move faster, but you don't want to move faster at the expense of getting things wrong or having things degrade in performance. I think everybody would rather continue to do what they're doing, um, but would rather continue to do what they're doing at the expense of moving faster, because if moving faster might mean that you introduce some error, which would be difficult to sort of explain or process for your users. So this is, as Pranav mentioned, part of a series of webinars that Arthur is going to be giving over the next couple of months. Earlier, we talked about formulating a strategy and assembling a talent. That was a webinar that our CEO gave. Today, we're talking about developing solutions that actually work. And in the future, we'll talk about things like adopting the correct risks and security posture and deploying to production, improving, observing, things like that. So, a couple of examples here, and really what I mean by let's move past vibes here is the vibe that we're starting to see emerge in the industry is it's really easy to start building these solutions. It's really easy to start building the software, but the vibe is, wow, this can go catastrophically wrong. And so Replit here, this is a tool that application developers can use. It's an agentic tool that will build an application for you. In this example, the vibe from Replit was it deleted a production database, lied about it, and it had to be interrogated in order to get information about what actually happened and why the production database went away. Similarly, Supabase, this is a database provider. They built an MCP tool that allowed application developers to connect to a database. But this MCP tool, the vibe of this tool was that it could leak the entire contents of your database, which, from a security positioning, is the worst case scenario for your users. Finally, there's this MIT report. This was a bombshell report that dropped a couple of weeks ago. The report indicated that 95% of generative AI pilots at companies are failing. What's really interesting here, actually, though, is if you read the report in a little bit more detail, they kind of broke down some more granular information about where they're seeing successes and failures. In particular, agentic or AI systems that are being developed for internal usage had about a 2 to 3 times more success rates at being deployed than AI systems where there were external users. And similarly, they noticed that companies that were spending time really thinking about solving for this trust problem, observing their AI systems, bringing a rigorous approach to the development and rollout of the systems had a much higher degree of success in getting these applications into production. So that's what we're going to be talking about today. So to kind of make it concrete, we work with an AI startup that that had this question posed to them. So this company is building AI agents, but before they could even build the product, before they could build the feature, before they could talk about the functionality of this feature, what it looked like, what the user experience was, they got a very consistent message back from their customer base, which was first, how can we trust the reliability of this agent? It's great that you guys want to build this for us. We see the promise of something like this and how it could be very useful for us and for our users. But we first need to understand what you're going to do to demonstrate and prove that this thing is actually going to work before we can talk about any of the specifics. And so we're going to walk through the approach that we took with this customer, this approach that we take with all of our customers. And really what it boils down to here is this AI trust checklist. Anybody who's thinking about deploying an AI system, whether you're building it, whether you're using tools that are on the market from vendors or self-building, regardless of what you're doing, you should be able to answer all 10 of these questions. And I think if you can answer all 10 of these questions in the affirmative, then that means that from the MIT report's perspective, you're in the 5% of companies that are getting positive return on investment from your AI system, or you're going to understand the AI system is probably not the right approach or the tool for the job, right? And so these things are all ways in which you can, as you're building and rolling out your AI systems, you should be reflecting on, you should be putting automation around, you should be putting process and people to help you answer these questions and to be continuously evaluating whether or not these are holding true. So to actually get into the meat and potatoes of what this looks like and sort of the strategy that we applied with our customers, I'm going to introduce some vocabulary, some terminology. The first thing we're going to be talking about today is data set curation. What I mean by data set curation, first, let's define a data set. A data set is recorded samples of inputs and outputs that define expected behavior. So if I'm working with an AI system, I put in a prompt, I put in some information, I'm expecting to get an output, and I want that output to be relevant. I want it to be helpful. I want it to answer the question that was being asked. And so when we think about curating these data sets, right, what this allows us to do is benchmark performance. And we're going to go into a couple of strategies that allow us to do this. But you can think of, for your use cases, for your applications, you have, 100, 1,000, however many golden truth standard questions and answers. And this is going to help you as you're developing your system, ensure that the reliability of that system, ensuring that these questions and answers are addressed accurately, which is going to help you build trust with that system. The next thing we're going to be talking about and defining today are evaluation metrics. Evaluation metrics are sometimes called evals. You'll probably hear me refer to them as evals going forward to the conversation today. These are quantitative measures that define the performance of a system and its components. They allow you to very quickly determine the impact or a change in performance to your system. So on the screen here are some very common evaluation metrics that you might be using or you might have heard of, or in the tooling that you're using might already be defined and exposed in a way. But we're also going to be talking today around what it looks like to build very domain specific evaluation metrics for the systems that you're rolling out. And then finally, we're going to talk a little bit about prompt management. So prompt management is the process and system used for defining the configuration that went into generating a response. So there's a lot that goes into this. We're going to be talking about all the different dependencies, the prompts, the models, the tools, the retrieval step, any documents that you're retrieving, embedding structures, things like that. But you can think of these usually as the independent variable for your system. So these are going to be the things that are going to be sort of changing, and then your dependent variable is obviously going to be updated to reflect that. So as you're working through and modifying your system, you might be making one change to one of these particular pieces, and you want to see what impact that has on the performance of your overall system, so that you can choose and pick sort of the best configuration that's going to work for you. So today I'm going to be talking through and referring to a couple of different user personas or use cases to make these examples a little bit more concrete. So whether you're building and rolling out an AI strategy, or whether you're building products using AI tools like agents or copilots or whatever, you need to be able to trust whether your investment is working correctly. So on the left here, we're going to talk a little bit about Bob. Bob is a go-to-market engineer, marketing lead. He's been working with a late-stage startup. He does revenue ops or rev ops. And so he's been tasked with building and developing an AI strategy for his go-to-market ops. You can think about pipeline generation, lead demands, so customer journey in the sales process. Bob sees a lot of advantages with using these new tools, but is unsure if they can be trusted to scale up. Right? Bob has a team of SDRs that are working and responding to these emails and account executives, and he's looking at the tools that are available today, like 11x, Sixth Sense, Clay, whatever they are, see a lot of potential. But if we're going to be changing up the way that the business is run when it comes to running these processes, once we start generating tens of thousands of emails, can I actually trust that all 10,000 emails are going to be generated in a way that are not going to make the company look bad? And on the right here, we have Sean. Sean is a CTO at an AI startup building a product using AI agents. Sean's team sees these agents as a way to unlock a lot of value for their customers, but he wants to ensure that his customers can trust the output of those AI agents because he's building a lot of value and taking a big bet on their ability to bring a product like this to market. This is forming a core part of their product strategy. And so being able to trust these things, ensuring that they're executing reliably, that they're protecting the information, are going to be very important details that they're going to need to pay attention to as they roll this out. So, as we walk through a couple of these different points that I introduced a little bit earlier, we're going to be using Bob and Sean as examples in sort of this trust building exercise for the problems that they're trying to solve. So, the first thing we're going to talk about here is how do we source good data for this data set curation piece? So, where and when do we source this data? Typically, this is a continuous process, but there are a couple of different ways that you might imagine gathering and capturing some of this data. The first thing here is dog fooding. So, this is data that is generated usually by your developers or your individual contributors, people who are working with and building these systems. When they build, when they test the system, they're going to be putting in different examples. They're going to be trying different edge cases. They're going to be trying different personas for sort of the users that are expected to operate in this system. Whenever you're using these examples, it's a great idea to capture these things and start being rigorous about what the expected behavior for what your engineers or your devs or your ICs are using when they're building the system out. So then the next place to think about sourcing data is using synthetically generated data. So this is data usually you use a large language model that's based off of some provided examples. So maybe you've captured 5 different examples from dog fooding, and you want to scale that up to 100 different examples. I'll talk a little bit about some strategies that you can use here for synthetically generating some data, but this is another way that you can capture this information. And then finally, you can gather information or gather data from live data. So this is data that's sourced from live interactions as people are using your system. It can be from human feedback. So for example, if you have a way of capturing good examples or bad examples from users, thumbs up, thumbs down, that's one way that you can maintain a data set. Or similarly, you can take information from a live stream. For example, take a random sample of all of the questions that were asked in the last month. It can sometimes be hard to source this data due to terms of service or data privacy agreements. So make sure that you're checking the legalese before using this information to help you refine or train your system. So now that we have an understanding of where this data can come from, the next question is how do we, as we're building out these systems, bootstrap the collection of this data and start using it to validate and refine the performance of this system? So typically this is a three-step process. The first thing you do is you capture some good examples. So as your developers or individual contributors are using the system, have a way of capturing those questions and answers. Even starting with something as simple as a spreadsheet here is a great way to capture this information. That way, as people start testing the system more, you bring new people on or you refine new features or whatever, there's always a golden standard location that you can go to and you can say, hey, these 5 questions always have to pass in this way. The next thing you can then do here is generate some related data using a large language model, like I mentioned the last time. So, some strategies when you're thinking about generating data and refining this information. Start with a good starting set. Make sure you're specifically prompting the language model. You want to be providing information such as these are the personas of the users that are going to be using it. These are the sorts of questions that they're going to be asking. This is the workflow that they're executing. The more specific with details that you can provide the language model and then you provide the examples, the better your output's going to be when it comes time to use the generated data. And finally, you're under no obligation to use all of the generated data. You should definitely take a pass over every example the language model provides and make sure that you're only selecting the ones that you believe represent a good, sort of understanding or a good, reflect a good example of what you might expect users to be actually saying when they use the application. And then finally, you want to refine this. This is a continuous process, right? One of the traps we see over time is that you might start with the data set and you might build out your system, and then you might continuously use this data set. But if you're never adding to it, if you're never removing records from it, if you're never updating them, you're going to be stuck in this process of, well, it worked at one time, but every time we go to make a change or every time we go to make an improvement, we're regressing behavior in some specific way. We're making improvements in some areas, but we're making it worse in other areas, and you're going to fall into this trap, right? So this is a continuous process AI systems are not like typical software where you buy a license, you deploy it, and then it just works over a period of time. You have to be continuously assessing these things as it changes because the models are changing, user behavior changes, and so you need to be bringing this practice of continuous evaluation, including continuous data set curation, to the rollout of your system, to the management of your system. So when we talk about continuous evaluation with these data sets, we talk about sort of data set curation. There are a couple of pieces here that I think are really important to capture as your system evolves. So on the left-hand side of the screen here, these are all logos for data set catalog providers. You don't have to use these. You can use spreadsheets, you can use other tools, whatever. But ultimately, the data set catalog systems are a great way to think about this curation process. And some of the functionality that these data set catalogs provide are: number one, they give you the ability to version your data sets. So with data set versioning, you have an immutable record of how well the system performed at an exact point in time. You can say, we used this data set at this version, which had these records in it when we assessed the performance. And that will give you an understanding of exactly how this was tested and how it impacted the performance of your application for a change. Similarly, you want to capture provenance. Provenance is useful for helping you to understand when something changed, why it changed, who changed it, so that if you ever need to go back in time to understand why performance shifted in a specific way or how did we fix a particular problem, you understand who made that change. You can go and talk to them. You understand why they made that change. Maybe you can go and look it up in a ticket somewhere to get some additional details. So something like source control is useful for this. And then finally, these data set catalogs provide an interface to serve these data sets for things like regression testing, right? So in this way, data sets serve the same purpose as like an integration or an end-to-end test of your application or AI system. So, excuse me, without the ability to reproduce specific behavior, you can still capture expected output for known cases. So, for example, right, these AI systems are all non-reproducible. They're non-deterministic systems. I can take the same application with the same configurations on the same versions, put in the same question that I asked 5 minutes ago, and get a completely different answer. This fundamentally breaks the way that we build and test software today. And so with these data sets, with lots amounts of data, you can now bring a statistical method to testing these non-deterministic systems to give you confidence that if I'm making a change, it's not going to create problems for me later on. So now we've talked about data sets. Let's talk about how we quantify success. This is where we're going to be talking a little bit about domain specificity. For somebody like Bob, right, who's doing this, go-to-market motion with AI tools, you might think for Bob's use case, he's going to be generating some marketing content. And when we think about how do we evaluate marketing content, we want to think about how well does it do at aligning to a particular brand? Is the tone on point? Is the formatting correct? Are we using the right colors? Are we using the right fonts? Are we using the right themes? Where somebody like Sean, who's building an AI agent, you might think that they're going to be looking at how well is this agent doing at analyzing data. So the metrics there that might matter are syntactic correctness, semantic similarity, how well is it aligned to the schema, right? For your different use cases, you're going to want to break down exactly for that specific domain what defines quantitatively the success of the system that you want to measure. So there's a three-step approach here that we found that is really useful in helping you break this down. So the first thing is you want to define what's important. So think about for your application or use case, understand the characteristics or components of a response that are necessary and important. So for something like marketing content, brand alignment is super important. We want to make sure that any message that's generated, any graphics, whatever, are aligned to the brand. Then the next step is we want to identify characteristics of a good or a bad response. What makes a response good? For brand alignment, right? This is aligned with the message that we want to send. It's aligned with the values of the company. What makes it bad, right? And once we have an understanding of what good or bad characteristics are, then you want to provide 3 to 5 examples of good and bad responses. And these are you're going to collect in your data sets. Use these to quantify or include in a prompt when measuring. So if I'm going to ask a large language model, hey, I just generated this graphic. I want to understand how well this graphic is aligned to our particular brand. Here are 3 examples, 3 good examples. Here are 3 bad examples. When we're talking about brand alignment, these are the things that are important. And when you go to prompt that language model to grade the response of that image that it generated, it's going to be able to give you a very accurate and reflective answer for how well that image generated fits that brand. So now we're going to talk a little about like what makes a good evaluation, what makes a bad evaluation. So a bad evaluation is something that returns a score between 1 and 10 or some numerical range, where a good evaluation is something that returns a 0 or a 1. For example, if I asked my evaluation, I want you to grade how well like, the semantic similarity. So for Sean, like, here's a SQL query. I want to understand for the SQL query, give me an answer between 1 and 10 about how well this SQL query is reflective of a gold truth SQL query. What am I going to do with the response that's a 4? What am I going to do with the response that's a 6? How much different is a 4 to a 6? It doesn't really give me a good understanding of what I need to do, take as a next step or what I can learn from that. So, a good eval is something that can give you an immediate feedback. It's either it passes or it doesn't pass, right? So, when I'm looking at the generated response for that evaluation, I have a really quick understanding of this missed the mark. We need to figure out why it missed the mark, or this passed. Great, we can move on. The next thing that's really important for evals is you should be generating these with explanations. So when it grades that eval, it gives you, hey, this didn't pass the evaluation metric. It explains why it didn't pass the evaluation metric. So for something like formatting in the marketing case for Bob, right? It's going to say, hey, this wasn't using the standard font, or the color scheme introduced a new color, which isn't in the standard set of colors that we care about or that we've defined for marketing content. So these explanations are going to form a very useful part for anybody who's coming in to look and understand why a particular change is going to work or not. Similarly, a very common trap that we see regularly with folks that we help integrate with is using these ready to use evals. Relevancy, recency, helpfulness, similarity scores, those kinds of things are all valuable in their own contexts. But if you're only applying the ready to use or generic evals and you're not using the domain specific evals, you're not protecting against the category of failures that your AI system might see that will eventually come to bite you when you go to scale up. So it's really important that you define these domain specific evals that are that for a particular use case, and you quantify those things and you monitor those things during your development cycle so that you have confidence, you can get trust that what you're building is actually going to be able to solve the problem for you when you scale from 10 emails to 10,000 emails. So finally, we're going to be talking about capturing these dependencies. And so I introduced this concept of prompt management, right? This is a way of really thinking about, okay, what are the particular knobs that went into my AI system at any given point in time? And what are the things that I can tune to dial in the performance of my application? So the first thing here are the prompts and the prompt templates that you're using. This is a specific prompt or variables that went into generate a response. So for somebody like Sean, right, you might think the prompt is going to be, hey, you're an AI assistant who's going to be answering questions and analyzing information, right? And so here's some various context. Here are some retrieved documents. Those are going to be templated out variables that are going to be applied when the system goes to make and generate a response. But you want to be able to capture what prompt exactly went into that generation. The other thing that you want to capture here are what models you're using and what parameters. So these hyperparameters are things like temperature, max tokens, etc. These are all settings on the model side that during the model inference are going to impact the performance of your application. And then finally, the last piece of information you want to capture here is the context. What tools were used? Was there any long-term memory? For the model, was there any planning tokens that were generated before generating the response? Ultimately, you want to answer the question, what was in the context window? What was retrieved during the retrieval step? What configurations were used? Those kinds of things are all necessary and important parts of generating a response. And if you're not able to capture what went into that inference, you're not going to be able to understand, when it comes time to measure the performance, what actually impacted the measure and what can I change then if we want to tweak certain things and try to improve the performance of this. Interesting to note here, especially in somebody's like Bob's case, right, where they're using tools, they're not necessarily building tools. Sometimes you're not able to have complete visibility or control over some of these different dependencies. So if you're using a tool like 11x or 6sense, right, you might not have the what model was being used and what parameters were being used, or you might not have access to the tools or memory or whatever. That's okay. You don't always need these things. I think you can sort of hold it as a black box as you're working through and evaluating system performance. But you want to be capturing as much as you possibly can that went into the generation stage, so you have an understanding of what the sort of things that you have the ability to tweak are and how that's going to impact the performance of your system. So once you sort of have captured all of these dependencies, then that allows you to do something that is very common in sort of the software world, which is A/B testing, right? So with A/B testing, your goal is to identify which prompt, which set of configs is going to perform the best for a specific task. You're going to measure those evaluation performance against different prompts, different configs, and the benefit of this, right, is non-technical users can now contribute in this process. You can have business analysts, you can have project managers, product managers tweak these prompts. They can tweak individual settings, and you can adjust these changes live along with user behavior. So as you're rolling something out, you could say, show me which one did better. Did prompt A do better? Did prompt B do better? And what we have here on the screen here is a screenshot from the Arthur platform. This is a tool that we provide that allows users to do this sort of A/B testing. In this case, this is sort of like an auto insurance use case where we have different prompts that are detecting damage to different cars. And for the particular domain specific eval we're using here, this is a binary classifier use case where you can see how it did against these different prompts at predicting sort of true positives, true negatives, false negatives, whether a particular car was damaged in particular part of the car was damaged in a specific way. So, how do we tie all this together then? We've talked about data set curation and sourcing good data. We've talked about quantifying success. We've talked about capturing our dependencies. So, now that we have all of these pieces together, we can really start to think about how do we use this to track our experiments. Ultimately, we see this as a continuous integration or a continue like a life cycle of building and developing AI systems. So, by quantifying this change, we can see these executions of these systems are non-deterministic. So in order for us to evaluate changes, we need to use statistical methods. So it starts with sourcing your data, bootstrapping that data, and using that data in development, right? So we need to build these data sets. We need to have confidence in these data sets. These data sets need to accurately reflect what our users are going to be asking and how they're going to be using our product. Then we need to define these metrics, right? So, what are the domain specific evaluations that we can bring to the table? What are some of the ready to use evaluations that we can bring to the table? And how are we monitoring these things? How are we paying attention to these things? Where are they plugged into the process? So that as we continue to make these changes, we can understand what the impact of those changes are in the development of our application. And then finally, we want to capture and tweak the specific pieces of configuration that go into the system. So if we're changing prompts, if we're changing tools, if we're adjusting our retrieval strategy, if we're adding new documents, taking documents away, what exactly are we changing here and how is that impacting the metrics? And then we can run our experiments. We can run 5 different changes in parallel and pick of those 5 changes, which one did the best against the gold standard data sets that we have. And that way I now have confidence that across all of the examples that I've provided across all of the different configurations for the very specific set of things that we care about, this change is going to be the one that's going to make the biggest improvement. And this is how we build trust, right? I've defined now a very quantitative, a very rigorous methodology for explaining how we're going to be protecting the user experience, how we're going to be building solid, scalable, reliable AI applications. And if you follow this continuous process here, every time you go to make a change, every time you implement a new feature, every time you roll something out, you're now going to be able to do that with confidence. So Bob and Sean, they can trust that following this practice is going to result in reliable AI systems. So what does this look like taking this beyond pre-production, beyond the development lifecycle? Well, here's where the good news comes into play. Now that you've rigorously quantified the performance of your application, all of the metrics that you used, all of the data sets that you've used, those are broadly applicable in both settings, in a post-production and a pre-production setting. So you can think about integrating this process into pipelines. You can, after bootstrapping this process, you can invest in automation, or you can schedule these things to run on a regular basis. Now you can hand over the sort of monitoring or practice of this application to your operators, who can now monitor this pipeline. They have the ability to make changes like we talked about with sort of the A/B testing framework. This can free up your development team. This can free up your resources that are building new features and making improvements to go focus on other initiatives, and give you the confidence that these operators now have the ability to manage a reliable application. And then similarly, you can bring the same practice into production monitoring. So these metrics, like I mentioned, are relevant in a production setting. These evals follow the application through the deployment lifecycle, right? So if it works in pre-production, it's going to work in post-production. Similarly, monitoring changes to these metrics using something like drift or anomaly detection can be a very useful way of measuring the performance of the system, even if you don't have good labels. So if you don't know what a great answer is for a question that a user asked, it doesn't really matter. You can take statistical techniques and monitor what all of the answers look like. And if the system spits out a really weird one, you can rank that pretty high on the list using anomaly detection and go in and investigate what exactly happened here. Figure out, was this a good answer? If it wasn't a good answer, what should have been a good answer? And then you can include that question and answer pair in your data sets and recycle through the whole system, giving confidence that future questions that look like this, you have the ability to answer correctly. So that's kind of the end of this. I think, ultimately what we do at Arthur here, what we believe is that AI observability needs to be continuous across the entire development cycle of an application. And we really think about this as a new way of thinking the software development lifecycle. This is the AI software development lifecycle, right? What we talked a lot about today was this pre-production evaluation. So obviously this is going to accelerate the development timelines with early issue detection. But like I mentioned, this same practice applies both to real-time runtime inference evaluations, building things like dynamic guardrails, which help you secure your application, make sure that you're protecting data privacy, make sure you're protecting acceptable use policies. And similarly, in the always-on production evals, this allows you to continuously monitor and improve your system while serving customers, and gives your operators the ability to action in a timely way feedback on system performance. And everything we've talked about today has been sort of within the generative AI case, but this applies all across the board to traditional machine learning, generative AI, agentic AI as well. So this is comprehensive support across all the different life cycles. And so if this is a thing you're interested in, definitely love to have a conversation with you. Feel free to reach out, please. But otherwise, thank you so much for coming to our webinar session. It was a great pleasure to talk to everybody today. As we mentioned, we're planning on following this up with a couple other webinars in the future. And so look out for invitations for those. But other than that, yeah, Pranav, any questions?
Yeah, we have a couple of questions, so I'll kind of shoot them. I'll start. I'll just say them out loud, and then you can answer them. So we have a question coming in from Ben. If we purchase software that leverages Gen AI, what questions can we get asked to get an understanding of how they're evaluating their models and processes? I would imagine some of these tools don't share this because it may contain information specific to their security posture and how they're protecting against prompt injections. Do you recommend that we set up these workflows and tests internally? That was the question.
Yeah, that's a great question. Thanks, Ben. So there are a couple of ways that we've seen this work in practice. I think, and this is an actively developing sort of market actually right now in the AI space. So to kind of make it concrete, so NIST or ISO, there are a couple of very specific standards that are starting to emerge today. I think ISO 4002, I believe, is the standard, and they're starting to think a little bit more about how can companies who are building AI certify through like an audit basically that their AI applications are secure and meet specific standards. So like I said, it's a little bit early. There are companies that are starting to adopt this. So this is one way that you can have the conversation, is you can ask sort of like, can I see a report for your ISO 40002 report? And if you don't have one, then like, hey, I have some questions about how you protect against, like prompt injections, or how you protect our data. Similarly, I think it's always fair to ask these companies for their benchmarks. So you can say, hey, I want to have an understanding of how you protect or how you evaluate your own AI systems. Can you share with us your benchmark data set so that we can run these in our environment? And I want to be able to compare performance in our environment with the performance that you're seeing in your benchmarks. And obviously, you're looking to see the alignment there, right? If the results that you're getting in your environment are wildly different than the results that they see in their benchmarking environments, then that's an indication that something might not be set up correctly, or something else is going on, and you want to talk to them about that. And then finally, I do think, to your point, like it's always a good idea to test these things out yourself, right? And specifically, if you're using these systems, you're going to be introducing new threat vectors. So vector retrieval is a really important one, right? Like you want to make sure that you're sanitizing any kind of inputs that are going into retrieval so that they, aren't prompt injection attacks or something, right? Or they're might not leaking sensitive data. And so it's always a good idea to, have a couple of different examples that you're using to test these things. And you can curate a data set, for example, that might contain sort of these are the things from a prompt injection perspective that we want to make sure that we're always testing against, and run those things regularly, like I described.
Thanks, Zach. We have two more questions. I think we could probably keep this like they're slightly shorter. So, yeah, one is my app's Gen AI feature is in beta right now. I don't have a lot of live user data. How many good or bad examples do I need to be able to create these domain specific evals accurately?
Yeah, that's a great question. We get this all the time. I think a lot of organizations right now, whether you're building AI products, don't have the users, or the larger enterprises are still trying to wrap their heads around like what's the right way for me to be thinking about my AI strategy and how do I build trust. So, I think the majority of the people are in this position, and sort of what we found when it comes to these domain specific evals and the number of examples that you can provide. I think a small kernel of test examples, like I mentioned in my bootstrapping. So anywhere between 3 to 5 to 10 really good examples from your developers, from your individual contributors, are going to form a very important part of this. And then using synthetically generated data, I think if you can bring that up to 50 to 100, that's going to form a pretty solid set there. And I think part of this here as well is, sort of when you're developing this software, you have an idea. It's really a hypothesis that your users are going to use it a certain way. But the reality is, no plan survives contact with the enemy, right? And your enemy here are the users. And so as soon as you go to make this thing available and your users start using it, they're going to use it in a completely different way than you thought that they were going to use it. And so, one of the things that you're sort of constantly and consistently evaluating through all of this is, you know, uh, how well did we do at specking out or defining good user behavior? And if you realize throughout this process that you have some examples for how you thought the users were going to be using the application, but these things aren't relevant at all, this is where that data set curation process comes into play. And you want to go in and you want to remove those things, or you want to update them, or you want to reflect that new understanding of the world in in the data sets that you're using. So I think, to succinctly answer the question, I'd say, you want somewhere between 3 to 10 sort of like developer curated examples, and then using LLMs, you wanna scale that up probably somewhere to between 50 and 100, and, you'll be in a pretty good spot.
Awesome, cool. I think we have a last question, um, which is a little open ended, but what do you advise for companies using open source LLMs?
Yeah, so I think in this case, there's 2 answers here. I think one answer is, everything that I've advised on, it works regardless of what LLM provider you're using. So if you're using Azure, you're using, OpenAI, DeepSeek, Anthropic, whatever, it doesn't really matter, right? You're treating these things ultimately as black box systems. And as you're thinking about your experiment tracking, one of the experiments you write one for your application is like, which model provider is gonna perform better for my domain specific task? If I'm generating an image for marketing content, is it gonna be Polygemma? Is it gonna be Anthropic? Is it gonna be OpenAI? Like, which one's gonna perform better if I ask it to generate, like 100 different emails, right? And so then I think the other advantage you get with using sort of an open source language model is depending on what your telemetry looks like or sort of your observability, you might have more insights from running the model yourself on how well it's performing, right? You might be able to explain, using sort of model interpretability or whatever, what exactly went into generating an inference. And you might have the ability to do some fine tuning using something like LoRa or some other type of reinforcement learning technique. And so that might form another dependency in that dependency chain that you might then want to use, when you're running your experiments, right? Maybe you've sort of trained a LoRa net on the final output of the transformer, and you might want to try different versions of that sort of trained model to be able to understand how that's going to impact the performance of your model. So it might give you some more of an opportunity to really dial in the performance if you're using an open source model.
Okay, I think we probably have the last 2 minutes for if there's one more question. Your webinar seems to be really popular, Zach. But yeah, we have another question from Ben. In your example where Bob is generating large amounts of emails, do the number of test examples need to increase? Say Bob is using a Gen AI to generate message for specific sales plays. Would the best practice be a generate tests would the best practice be to generate test cases for each play or type of prompt that he's using? How can this be applied to other forms of media such as pictures?
Yeah, it's a great question. So, a couple things that I'm pulling out of this. I think, in terms of like the number of records in your data set that you want to use, I think the same answer that I answered earlier applies. You want to keep this at about 3 to 10, sort of like human generated examples, and then 50 to 100 synthetically generated. Or if you're able to replace those with live data, then you can replace some of the synthetically generated examples with that live data. But I think 100 examples is probably near the ceiling of what, would be useful. But when it comes to thinking through, you have different expected user workflows or different behaviors, I think those are all things, you might want to put domain specific evals around. So if you have, one user group that's using the application in one way and another user group that's using the application another way, I would definitely recommend, ensuring that you have examples for sort of both of those personas in different data sets, and you're testing both of those workflows individually, right? The risk you run when you use the same data set for multiple different sort of workflows is that you're capturing sort of the generic output, but you might be missing out on being able to test very specific pieces of it that might be really important when it comes to scaling up to 10,000 emails or whatever it is, right? And the same goes for image generation, right? If you have an image generation task that's generating example marketing content, maybe like ads, then, if you're thinking about something that's building, very specific generic on brand ads, you might want to test that. But if you're, building ads for a very particular persona that's targeting, a very specific market, you're probably going to want a set of evals to monitor for that particular market that makes sure that you're quantifying how well is the image generation at reaching this particular person in the audience that I care about.